Good afternoon, Year 10. Hello. How's everyone doing this afternoon? Everyone still feeling a bit cabin fever-esque? I'm just pausing my other laptop. Guys, thank you so much for having a go at the worksheet. I know that not everyone's managed it. Got 7 out of 8 of seven handed in, 8 not handed in. So well done to those people. Honestly, I really appreciate all your efforts. It does make a big difference, I swear. What is going on Donkey Kong? Sup, Zach? Zach, have you handed in your homework? I'm handing it in now. Awesome, good job. Good job. Zach, have you done your homework? Hi, Tiffany. There you go. I've just had, I think Anania's has just come in. No, Audra's is in, Amani's in, Tiffany's in, Halping's in, Dom's in, Caitlin's in, Atia's in. Oh, it doesn't work. What doesn't work? Tiffany, I've got yours. What doesn't work? Zach, 3 questions. Hi, Halping. Who is the face? Well, it doesn't work. Our prank. What are you trying to do? What's going on? I feel like there's something going on here, folks. Is it because it's April Fool's Day? It is, isn't it? Can I ask, Tiffany and Laura, is that my face? Oh my goodness, you're all putting my face on your profiles. Guys, that is the weirdest thing ever. Oh no, what's that picture? That is so embarrassing. Oh man, I can't see it very well. Like, if I click on it, does it make it bigger? No, it really doesn't. But I now see my face everywhere. Guys, that's so embarrassing. It's not, it's like, it's me making a really weird face as well. Oh, and you're all zooming. Oh, you guys are mean. Oh, man. We can send it. Everyone did it. Babe, you should see that. They've put their profile picture as my face, all of them. Little tiny pictures of me. Isn't that just hilarious? Take a screenshot. Oh, it's really, what's interesting is it hasn't updated it on my little one, on the one that I use here, but it has on the YouTube screen. If I, there's my second, let's take a screenshot. Oh, I can take a screenshot. Yeah, I can try that. All of the faces. I'm not entirely sure how to do that with this thing. Uh-oh. Oh no. Oh no. Oh, I think I may have just done it. I think I may have just taken, oh no. Stop. Yeah, I don't know. I've just clicked there. You guys are causing trouble. I've no idea whether or not it's done that. I don't think it has. I don't know how to take a screenshot. Oh, maybe it took one then. Don't know. Oh, screenshot. I have a picture. Yay! I have a photo with my face on all of them, except for Sophia's now. It's amazing. So, do you know what I need to do? I think it's vitally important that I just changed my profile pics. Do you guys see Mr. Duncan? No, Dom, you're still normal. So what I now need to try and do is I now need to try and recreate that one of like this. Is that my face? I think that's the face. Oh, you guys are funny. Right, let's do the register. Have I got Amani? Where's Amani? Has anyone seen Amani? No Amani yet. I can send you the picture. Yeah, definitely do that. That looks awesome. Can't see Amani, but I've seen Zach, seen Sophia, seen Tiffany. Has anyone seen Kayla? Haven't seen Kayla yet. Have you seen Mel? Seen Mel. Audra, Sophia. Sorry, Lara's here. Atia's here. Ananya's here. Caitlin? Amani? Yeah. Ah, fab. There's Amani. Do I have Kayla? Kayla is coming. I like it. Mel's here. Like it. Audra? Her Wi-Fi is really bad. Fair enough. There's Caitlin. Amazing. Dom, I've seen. Ryan? Is Ryan here? Has anyone seen Ryan? She can't access it. That's weird. I haven't got a clue. Maybe she needs to make a YouTube account. I've seen Lynn. Has anyone seen Libby? Is Libby here? Haven't seen Libby yet. Definitely seen Hao Ping. Just Libby, Ryan. Ah, there you go. There's Libby. Hi, Libby. I'm just missing Ryan, Kayla, and Audra. Yeah, she's here. What is that, Audra or Kayla? Is that here? Or is that Libby? What's the delay? Right. Okay, I'm going to crack on with that. Audra is here. Amazing. Kayla? Ryan? No idea. Audra is it? Yeah, we've got that. Okay. Well, I'll mark them as not in for now. No one heard from Ryan then. Okay. Oh my goodness, that's the face. Is that when I blew the balloon up and it burned my arm? That's what the picture's from, isn't it? Oh, that's such an embarrassing picture. I ought to share my wow. Thanks, guys. Thanks so much for that. You guys make me laugh. Right, let's crack on, folks. Have you ever had a dream that you could wanted to do so you that what? Does anyone know what's wrong with Atia? Yeah, is she all right? Has she got a stutter? That's so funny. Oh, it's amazing. Still haven't seen Kayla. Anyway, oh, Ryan. Ryan's here. Hey, Ryan. Sup, dude? Sup. Just Kayla missing. All right, I'll save that. Okay, guys, let's crack on, shall we? Let's share screen. Hello, Mr. Screen. There we go. I'm now suddenly aware that I can't make silly faces with you guys because you'll photograph me and then put it onto your profile pictures. Who disliked the video? Oh, somebody disliked my video. Oh well, you know what? I think I'm confusing myself for someone who cares. Right, let's crack on. I love the fact that Mel's just laughing. Amazing. Right, so guys, today. Oh, guys, do you know what today is? Oh, it's so sad. Do you know what today is? It's the last time I teach you now for a couple of weeks. Oh, it makes me sad. So this is Reacting Maths Part 2. That's what we're doing. I'm now going to just... So first thing I want to do, folks, is go through your homework. I know. Can you believe it? Guys, this is our last lesson for 2.5 weeks. Can you believe that? It's so sad. Makes me sad. Makes me so sad. Right. Ugh. Yank my keyboard off. Right. Okay. Let's have a look, shall we, folks? Let's go through the answers. Can you just make any corrections that you feel like you need to make? Okay. So calculate the mass of aluminium that is formed from 1,000. Okay, so step 1, get to moles. Number of moles is grams over rams. So number of moles is 1,020 grams all over. What's the relative molecular mass of aluminium oxide? Well, aluminium is 27 times by 2. I'm going to add that to 6 oxygen, which is 16. Yeah, oxygen, which is 16 times 3. Total number for aluminium oxide, 27 times 2 plus 16 times 3. It's gives me 102. Oh, look at that. By the way, if it was A level, it'd be 0.0. No, nice to throw that in there. So it's 102, so over 102, which gives me the number of moles of 10. 10 moles. Right. Now I need to use step 2, is use this is get to moles, and the next one is ratio. So what's the ratio? The ratio is 2 to 4 to 3, but I actually only need this one to this one. That's all I need to do. So it's a 2 to 4. That's the same as a times 2. So I'm going to take 10 moles and I'm going to times it by 2, which is going to give me 20 moles of aluminium. Next, final step is step number 3, get out of moles, get back to grams, reorganize that. Moles times rams gives me grams, which is going to spit out, so 20 multiplied by the relative atomic mass of aluminium, which is 27, and I get 20 times 27, and I get 540 grams. Does everyone get it? That's it, all to 3 sig fig, which is great. It's really nice to check this. We can now make a guess, because this is going from this to this and this. Well, if I'm making 540 grams of that, and I started off with 1,020 grams of that, I can just do 1,020 minus 540, and I'm going to get 480 grams of that, just using conservation of mass. But we can prove that then, can't we? I think it's quite nice to do. What was the ratio? The ratio was 2 to 3. So if I take those 10 moles, I'm going to have to divide by 2 times by 3. And by the way, this is just me being a nerd now, guys. So if I take the 10 divide by 2 times by 3 gives me 15. I would have had 15 moles of oxygen, moles of O2. Then multiply that by the MR, which is 32. 32 times 15, and I get 480 grams. Isn't that magic? Magic! Whoop, whoop. Winner. Nah. So that's my answer. Faux sure. Faux shizzle. I'm sorry, I didn't mean to say that. I'm sorry. I don't know. I didn't say faux shizzle. Calculate the mass of oxygen needed to react with 10 grams of calcium. Right. I've got 10 grams of calcium and I want the oxygen. So step 1, get to moles, grams over rams. Grams over rams. So I've got 10 grams over. What's the relative atomic mass for calcium, which is 40? So 10 over 40 is going to be 0.25, right? Yeah, that gives me 0.25 moles of calcium. Next, step 2 is my ratio. My ratio is 2 to 1. Yeah, ratio is 2 to 1. So I need to divide by 2. So I'm going to divide that number by 2. So 0.25 divided by 2 gives me 0.125 moles of oxygen. Step 3, get back to mass. Yeah, get out of moles. So I'm going to do number of moles times by rams gives me grams. So what does oxygen weigh? 0.125, and oxygen, of course, always weighs 32. You see why after a while you get used to this, folks. I'm going to need 4 grams. Boom. Nailed it. Let's just check the calcium oxide. The calcium oxide would have been in a 2 to 2. So I would have got the same number of moles of calcium oxide as I would have calcium. What's the weight of calcium oxide? Which is calcium is 40 plus oxygen, which is 16. So that's 56. Multiply that by 56. 0.125 times by 56, and I get 7. So does that all add up? So I had 10 grams of him. I had 4 grams of him. I should have 14 grams. I've just got half of it. What have I forgotten to do? Did I forget? Oh, hang on. Moles. Oh, I didn't. Sorry, used the wrong moles. There we go. Those are the moles I should have been using. Moles of calcium. That's moles of Ca, yeah? And that's a 2 to 2 there, so it should have been 0.25. 0.25 multiplied by 56, and I get 14 grams. Winner. There we go. Winner. So it's just checking my 4 grams is definitely correct. Next, what mass of propane could burn in 48 grams? So I want that guy, and I've got 48 grams of oxygen. Right. Step 1, get to moles, grams over rams, over oxygen, which is 32. We're getting used to this now. 48 divided by 32 is 1.5. 1.5 moles of oxygen, of O2. Next, step number 2, use the ratio. Yeah, what's the ratio? It's a 5 to 1. Oh, it's a 1 to 5, but I'm going in that direction. That's a divide by 5 step. So 1.5. Oh, Mr. Duncan, I hear now my Wi-Fi is really bad. Oh. Kayla, you're in. Thank you so much. It's lovely to see you. Lovely to see you. There you go. You're in. Awesome. So I'm going to take that 1.5 and I'm going to divide it by 5. Yeah, so 1.5 divided by 5 gives me 1.5 divided by 5 gives me 0.3 moles of propane. I like it. Yeah, of 3 moles of propane. But then next step, get out of moles, times it by the MR. 0.3 multiplied by propane, 44. Carbon is 12 times 3, which is 36, plus 8 is 44. Propane multiplied by 44, and I get 13.2 grams. Tick it if you've got it, folks. Booyah! Yeah, nailed it. Next, what mass of ammonia? So what mass of ammonia from 20 grams of hydrogen? Right, step number 1, get to moles. Number of moles is grams over rams. Yeah, so I've got 20 over, what does hydrogen weigh? It's the lightest of all the elements. It weighs 2, because hydrogen on the periodic table is 1, but it's in a pair, so it's 2. Yeah, H2 equals 2. Yeah, yes, everyone okay with that? So I'm going to get 10. I have 10 moles of, I don't know what, no, sorry, 10 moles of hydrogen gas. There we go. What's the ratio? 3 to 2. Step 2 is the ratio. You got to roll your R with ratio. I think that's Italian. And then we do 10 divided by 3. Yeah, divided by 3, because the ratio is a 3 to 2. Divide it by 3 to get it to 1, and then times by 2 to get it to 2. Yeah, so 10 divided by 3 gives me 3.333333333, and then I'm going to multiply that by 2 times 2 gives me 6.67 moles. Mole. Going once, going twice. There's my ratio. So there's, I'm going to move that over to here. Ratio is 3 to 2. That was a hard one, folks. Ups the level that if you have an uneven ratio. And that's going to be moles of ammonia. Next, need to get step 3, get out of moles. Yeah, so number of moles times rams gives me grams, which means I'm going to have moles of 6.67 multiplied by ammonia. Nitrogen's 14, hydrogen's 1 times 3, 17. Multiply that number by 17, and I get 113.3 grams. 3 sig fig, 113 grams. Winner. Next, number 5. What mass of sodium hydroxide is needed to neutralize? Whoa, we got kilograms. Holy moly, that's a lot of moles. holy moly. No. I'm sorry. Step 1, get to moles. Number of moles is grams of rams. Well, how many grams? That's a lot of grams. 24.5 kilograms is equal to times 1,000, which is equal to 24,500 grams. Divide that by, sulfuric acid. Sulfuric acid is hydrogen is 1 times 2 plus sulfur, which is 32, plus oxygen, which is 16 times 4. Sulfuric acid, 2 plus 32 plus 16 times 4, 98. So divide that by 98. It's going to give me my moles. 24,500 divided by 98. It's a lot of moles, 250 moles. 250 moles of sulfuric acid. I like it. Right, second step, ratio. The ratio is 1 to 2 going in that direction. So I'm going to multiply it by 2. 250 times by 2 gives me 500. I need 500 moles of sodium hydroxide. Holy moly. So now step 3, get out. Yeah, get out of moles back into grams. So we've now got number of moles equals grams over rams. Reorganize it. Number of moles times by rams gives me grams. So I have to multiply that by sodium hydroxide. Sodium hydroxide, sodium is 23, oxygen is 16, hydrogen is 1, total number 40. So that's 500 times by 40. 500 times 40, whoa, gives me 20,000 grams or 20 kgs. Whichever one you prefer, folks. I don't mind. Yeah, everyone with me so far? Smashing through this, guys. Killing it. Next, question number 6. What mass of carbon dioxide is formed when copper? Okay, so we've got 7.41 grams of him, and we want the amount of CO2. Well, that's nice. The ratio is 1:1. That's easy. Step 1, get to moles. Number of moles is grams over rams. 7.41 over copper carbonate. 123.5. I don't know, I think. Copper on your table is 63.5 plus carbon, which is 12, plus oxygen 16 times 3. So 63.5 plus 12 plus 16 times 3, 123.5. Wow, it's really sad that I know those kind of numbers. So sad. Such a nerd. 7.41 divided by 123.5 gives me 0.05. Oh, look at that. Round, round, round. 600 moles. Isn't that cool? I like it. I like it. Right, that's the moles of copper carbonate. That's moles of CuCO3. Step 2 is the ratio. It's still going to be worth a mark in the exam. 1:1. That means 0.0600 moles of CO2. Right, step 3, get out of moles. Number of moles times by rams gives me grams. So therefore 0.0600 multiplied by 44, 0 times by 44, and I get 2.636, no, 64, there we go. 2.64 grams. Done. Next. On to the next page now, folks. We're smashing this. With 4 questions to go. Booyah! Yeah, try to keep up. So what mass of carbon monoxide is needed to react with 2.08 kgs of iron 3 oxide? Do you see the problem there, folks? I hope everyone's going, wow, these worksheets aren't written properly. That should actually be iron 3 oxide. And you're meant to be saying it in that particular voice, by the way. Oh, yeah, that's not actually iron oxide. That's actually iron 3 oxide. That's exactly how you're meant to do it. So step number 1 is get to moles. Number of moles is grams over rams. So I've got 2.08 kg. Can't use that. Multiply it by 1,000 to put it into grams. 2,080 grams. Grams over rams. What's iron oxide? Oh, iron oxide. 180. I don't know. 160, 40, 30, 20. I don't know. 56 plus 56 plus 16 times 3. 160. So divided by 160, 2080 divided by 160 gives me 13 moles. 13 moles. Step number 2, use the ratio. And the ratio is 1:3 going in that direction. So I'm going to multiply this by 3. So 13 times by 3 gives me, 13 times by 3 gives me 39. 39 moles of carbon monoxide. Now, step 3, get out of moles. Yeah, step 3, number of moles times by rams gives grams. So I've got 39 multiplied by carbon monoxide is 12 plus 16, 28. Times by 28 gives me what? 39 times 28. Was it 39? Yeah, 39. Times by 28 gives me 1,092 grams. Or 1.092 kilograms. Whichever one you prefer. Smashed it. Next. Right. What mass of chlorine reacts with 20 grams of iron to form iron 3 chloride? I want the chlorine. Step number 1, get to moles. Number of moles, grams over grams. So I've got 20 grams over iron, which is 56. It's actually 55.8 for A level, but whatever. 20 divided by 56. It's going to give me 0.357 molars of iron. The ratio, step 2 is the ratio. Ratio is 2 to 3. Yuck. That's a pain. Right, divide by 2 will get me to 1, and then times by 3 gets me to 3. So divide by 2 times by 3 gives me 0.536 moles of chlorine gas. Right, now, last step, get out of moles. Isn't it 2.63 for the last question? Oh, have I made a mistake? 2.63. Have I made a mistake? 2.63? Where's 2.63? Which one? 2. Oh, is it 2.63? Yes, probably. Yeah, probably. Because if I do 7.41 divided by 123.5, oh, yeah, that gives me exactly 0.06. Yeah, multiply that by 44, 2.64. I know why, Sophia, it's not your fault. I think it's because in your periodic table, are you given copper as 64? I bet you that's the answer. Sometimes the GCSE, I can check actually. Hang on, I can check. On your periodic table, this is the Edexcel one. This is the one that you're going to get in your exam, and it's 63.5. So no, it'll actually be that. It'll be the number that I got with. I don't know whether or not you just used a different periodic table. Totally possible. Step number 3, number of moles times by rams gives me grams. Next, so I'm going to go 0.536 multiplied by chlorine, which is 71. It's 71 because chlorine is 35.5, but it's in a pair, so times by 2. Yeah, so times by 71, and I get 38.1 grams. Tick it if you've got it, folks. Next, hydrazine. Ooh, rocket fuel. Ooh, hydrazine, scary stuff. Very explosive. Right, zoom in a bit. So hydrazine is used as well. It can be made by reacting ammonia with hydrogen peroxide. What mass of ammonia is needed to make 148 grams of hydrazine? Perfect. So step 1, get to moles. Grams over rams. Yeah, grams over rams. 148 divided by, what's hydrazine? Nitrogen is 14, but there's 2 of them. Times by 2 plus hydrogen, which is 1 times 4. No idea what that is. 32? It's 32, isn't it? 14 plus 14 plus 4. 32. Yeah, there we go. So divided by 32, 148 divided by 32 gives me 4. 148 divided by 32, yeah, it gives me 4.625 moles of hydrazine. Agreed? Cool. Okay, next. So step number 2 is the ratio. You always get a mark for writing it down. The ratio is 2 to 1, but we're going in that direction. Would everyone agree? There's an invisible 1 there. There's a 2 here. Yeah, is that okay? I think he rounded it. Yes, same. Yeah, I got that too. Okay. Isn't it 38? Oh, I used to go. 38, 38.0, possibly. I probably rounded it. It's fine. If there are rounding errors, you can have it. I'm not too fussed. Yeah, in your exam, we'll focus on that when we get closer to your actual exam. Yeah, so we're going to multiply this by 2. This is a times by 2 process. So we're going to take those moles of 4,625 times that by 2. And I get times by 2, kept on my calculator, 9.25 moles of ammonia. Get out step 3. Get out of moles. Number of moles times by rams gives me grams. So 9.25 multiplied by ammonia, which is 17. You kind of get used to doing this after a while. And you get 157.3 grams. Booyah. Smashed it. Next. I got 37.5. Yeah. Oh, funny rounding out. Sorry. Right, guys, the only question of real interest. This is a good one. This is a good one, folks. Right. Are you ready, year 10? I know this was a challenge question. I'm going to be teaching you how to do these on a separate webinar. These questions here are called water of crystallization. Water of crystallization questions, Qs. That's what these are. They're a very particular set of questions. But you could definitely have figured it out. It's all about counting particles, remember? So, number one, I have got, I'm going to try and highlight, I'm going to get rid of that gram for a start. Okay, I have got 10 grams of hydrated, so let's input that data. So I have got, on this guy here, I have 10 grams. Right, decomposed to form 4 of anhydrous sodium sulfate. So I now have, I'm going to do this in colors. So there's my yellow, and then here's my green. Anhydrous means without water. Yeah, so I have now got 4.4 grams of that guy. That means for 1 mark, I can work out mass of water. Mass of H2O equals 10 minus 4.4, because this is the one with the water. This is the one without the water. So I'm going to end up with 5.6. Still doing it on my calculators. Don't trust my maths. 5.6 grams of H2O. Agreed? Right. Okay. So now we want to find out what the value of X is. Well, would you agree we need to count these particles? That's exactly what we need to do. We need to count how many sodium sulfates we've got and how many waters we've got. Right. So moles. Moles is the way to count particles. Yeah, by the way, there's 1 mark for that, folks. 5.6. So we now need to count, because moles means the number of particles. We can just treat 1 mole as 1 particle if you wish. It makes no difference. The concept is the same. So how many particles of sodium sulfate did I have? Number of moles is grams over rams. Well, I've got, my number of moles is 4.4. What does sodium sulfate weigh? Right, so sodium is 23 times by 2. And I'm going to add that to 32 for sulfur. And I'm going to add that to 16 times 4, which is oxygen. So I'm going to add all those together. So I'm going to get 23 plus 23 plus 32 plus 16 times 4. I'm going to get 142. 0.0 at A level. So 4.4 divided by 142 gives me a number of moles of this guy, 0.0310 moles. So that's how many particles I've got. Right. How many particles of water do I have? Well, I've got number of moles is grams over rams. Number of moles is 5.6 divided by 18. We all know by now that water weighs 18, oxygen weighs 32. We get used to this game. 5.6 over 18, and I get 0.311 moles. Now, guys, here's now the lots of you will have got to this stage. Yeah, you'll have got to that stage. Now, here's the genius bit. Would everyone agree that in this picture, I have one of these guys. There's an invisible one there. Does everyone agree? And then an unknown number here. Well, how do I get my number, my moles of sodium sulfate? How do I get that to the number 1? I'm going to divide it by itself. If I divide that by itself, I will get to the number 1. Well, if I divide the water by that same number, I get 1. The value of X was 1, folks. Isn't that crazy? Is that right? No, it's not. I'm an idiot. I haven't actually done the maths. That's why you should never do it in your head. I'm an idiot. There's 0 in there. 0 divided by 0.0310. And I get a value of 10. The value of x is 10. It is. The value of x is 10. X equals 10. Ticket if you got it right, folks. I didn't expect that was just a challenge question, really. Oh, boy, I got 10. Nice one, Atia. Well done. Good job. Isn't it genius? Isn't it clever? Oh, it's great to be able to count particles. It's amazing what you can do with it. Like, seriously. Like, awesome. Okay, guys, today's lesson. Reacting mass part 2. Reacting mass part 2. Oh, do you know what? No, I really do want to do this. I really do. Okay. I'm going to have to give you guys some lessons over Easter because we're a little bit behind. I have to finish off the calculations topic before we go back because at some point at the end of the year, there's going to be a test. Oh, I thought I was doing it wrong. Is the formula mass 322? Yes, probably. Yeah, it probably would be. Oh, I know what you did. You've done something clever there. You've said that the moles are going to be the same, didn't you? Therefore, you can work out the MR. Yeah, it works. It works fine to do that, Lara. That's okay. So the MR of this guy, yeah, you realize because it's a 1-to-1, one of those has produced one of those. The moles of this is going to be equal as well. If we go for the whole thing, there is another way round here that Lara's spotted. The number of moles there is also the number of moles of that in total. So I've got 0.0310. Well, how many grams of it did I have? I had 10 grams of it. If we do number of moles equals grams over rams and reorganize for rams, oh, hang on, please don't do it in the morning. I can't wake up because it says to calculate the formula mass of that. Oh, does it? Oops, calculate the value of x. Oh, yeah, my bad. I haven't finished, have I? Lol. So I want the rams, bring that up. Times that by rams, bring the moles down. That'll do it too. There you go. Grams over moles will give you rams. So grams over, so 10 divided by that number. 10 divided by 0.0310 gives me 322. There you go. Perfect. 322 is the relative molecular mass, Rm. It's actually relative formula mass, isn't it? Yeah, because it's ionic, RFM. So there's your answer, folks. Yay! You could have also done it this way. You could have also done, well, if I've got the MR 142 of just that bit, I could have added that on to 10 waters, which is 90, which gives us 322. Isn't that clever? You can go around this a whole load of ways. But it works. Yay. Okay. Right, guys. Oh, can you mark it, please, and give me a number? Yeah. Give me a mark it. Give it a mark. So it's just, if you got to the right answer, you know, then you can have the 1 mark for each question. 1, 1, 1. Yeah, if you got the right answer for this one, I don't mind. And then 2 marks for that guy. Yeah, you can have 10 and 322. I don't know how many marks that's out of now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's out of 11. For question 8 is 38 point. Right, yeah, you can have it. Yeah, have it today. Definitely. It's the process that matters to me, Lara. Yeah, it's fine. Right. Can you not do the lessons in the morning? I'll look into it for you. Shish kebab. Right. Reacting mass part 2. So, great job. Thanks, Dominic. Well done. Good job. How Pings put 11 o'clock. I like it. Well done. 11:11. Good job. Good job, guys. Well done. I hope you realize that has just taken us most of the lesson, hasn't it? Blimey, we only got 15 minutes left. Okay, guys, I need to crack on. So, this is now reacting mass. I'll make, yeah, I'll zoom out a bit. There we go. So reacting mass, and you're going to realize that this is exactly the same, part 2. So what I want to do now, guys, is I just want, thanks guys for putting on your answer for your count, that's great. So does that count as 11 out of 11? Yes. Right. So we've been using grams, you realize that we've been hammering grams over rams there. Well, there are questions which are just going to use a different moles equation. So I just want to put you into the next context. So if I had an acid and a base, acid versus base, yeah. Wait, Mr. Duncan, I don't really get the part about X. Like, what is X supposed to be? Oh, okay, good question. So, okay, so that's a good question, that. When salts, Mel, when salts form, oh wait, never mind, that's okay. When salts form, when you've got a beaker of salt water, yeah, and you've got the salt in it, when the water evaporates and the water goes down and you start forming crystals, some of the water will be trapped inside it. And the structure of the crystal actually decides the number of water molecules that can be trapped in the lattice. And in this case, it's 10. 10 per. So if you imagine our repeating unit, we know that our giant ionic lattice is positive, negative, positive, negative, positive, and it just goes on forever. Yeah, we've got our giant ionic lattice. Well, what we know is that some of these kind of particles, there are structural gaps. The sulfate is a classic, of course, because the sulfate, we've got sodium plus a simple ion, followed by S, this followed by the sulfate ion. I'll draw it like this to make it easier to understand. Yeah. This is the sulfate ion. Yeah, there's the sulfate ion. And then another sodium there. And then we'll get another, it'll build up like this, yeah. Well, there are gaps that water can sit in, yeah, and you'll get water molecules trapped inside a solid crystal. And these are called water of crystals, crystallization. Are the lessons over Easter your April Fool's prank? No, Caitlin, it isn't. I'm happy, do you know what? I'm happy not to do them if you don't want me to. If you don't want me to do them, if you guys want to just have a break, I'm happy to give you guys a break. Let me know. So I hope that answers your question, Mel. So if we put ourselves into a situation where we have an acid and a base. So if I have hydrochloric acid, if I have HCl, and I react it with sodium hydroxide, I know that they're going to react and they're going to become sodium chloride and water. Yeah, we know this. Metal hydroxide plus acid, salt and water. We get that from our previous lesson, from our equations one. So now let's say somebody gave me an acid to find out. Let's say I've got 25 centimeters cubed and I've got a concentration that's a vol and a concentration that's unknown. If I now add to it a known sodium hydroxide, something that I know everything about. I mean, if you could film them on YouTube and leave them there, because if it's live in the mornings, just wake up earlier. I don't know when I'll do them. I don't know. You're putting me off already. So, okay. Let's say we add 18 centimeters cubed of sodium hydroxide, and it was 0.5 moles per dm cubed. We realize we're starting to pick up all kinds of things here. Yeah. So we now have a volume, a vol, and a concentration, and we have enough to get to moles. And the process becomes the same. Whenever you get, well, this question is just another reacting mass. Step one, get to moles. Well, that's volume and that's concentration. This is number of moles is C times V over 1,000 because I'm in centimeters cubed for volume. Right, spit it out. So I go, oh, okay, so my number of moles is going to be C 0.5 times by a V of 18 all over 1,000. Run it through my calculator, 0.5 times 18 all over 1,000 gives me 9 times 10 to the minus 3 moles of sodium hydroxide. Right. Step 2, ratio. What's the ratio? It's a 1-to-1. That's nice. Gonna get a mark for writing down 1-to-1. There we go. Which means the number's the same. Therefore, 9 times 10 to the minus 3 moles of HCl. Step 3, get out of moles. Out of moles. But this time, I'm looking for its concentration. It's giving me a direction. It's why it's slightly harder. They're wanting a particular piece here. Number of moles is C times V over 1,000, but I'm after C. Reorganize. Bring the 1,000 up. Moles times rams. Bring the V down. Over V gives me C. Right. Input my data. My moles of hydrochloric acid is 9 times 10 to the minus 3 times by 1,000. And what was its volume? 25. So 9 times 10 to the minus 3 times 1,000 divided by 25. And I get a concentration of HCl, concentration of 0.36 moles per dm cubed. This is not complicated, folks. It's just we've stepped into a new equation. And in some regards, some people find this slightly more tricky. Other people find it's exactly the same, and they go, it's the same process. And it is. And that brings me to the end of my lesson. So what I'm going to do, folks, I'm going to post on the classroom a set of questions, and I'd really like them to be done, obviously, I'm going to say by the end of the holiday, but that then becomes pointless because you won't remember it. Could you have it done by the end of the weekend? I'll post that worksheet on the class. But that actually finishes my lesson. Let's see if I can bring you guys back. Hey guys, we're done. We're done. It's been awesome seeing you guys as always. Thank you so much for doing the homework. I know it's always tough. And I know I didn't give you an awful lot of time for it, but I promise you it will make you better chemists. Doing the homework straight away, reinforcing this methodology is so, so, so important. It'll hold you in good stead for the rest of your lives. Guys, have an amazing Easter holiday. It's been great to see you guys. If I do a webinar, I'll send out an email, but I won't expect people to come if they don't want to. I'll see you soon, guys. Take care. Bye now.